This video shows the mechanism for the Stork enamine synthesis, including the formation of the enamine and the hydrolysis of the enamine. We start with our secondary amine and our ketone in the presence of acid. And the first step that you will remember that this is a reaction where we used the proton dance. So the first step in the reaction is proton on. The ketone is protonated at the oxygen to give us this cation intermediate, which is more susceptible to nucleophilic attack by the nitrogen. So the nitrogen amine attacks the cation intermediate at the positively charged carbon to give us this positively charged intermediate, which is then deprotonated. Proton on, something happens, proton off. Okay, now we have this intermediate with both the nitrogen and the oxygen attached to the same carbon. We protonate the OH group, and now we have water, which is a good leaving group, so we get this cation intermediate that's resonance stabilized. The next step is deprotonation of that intermediate to give us the enamine. Okay, now we have the enamine. We're going to react it with an enone, which we might recognize as a Michael acceptor. The enamine is the nucleophile, and it looks like an enolate attacking because the lone pair makes a double bond and the alkene acts as the nucleophile to attack at the beta position. So now I have this intermediate that's got a negative charge alpha to the carbonyl and a positive charge on the nitrogen, so it's an iminium ion. So the first step is to neutralize the anion, so there's only one charge on the intermediate. And then the next steps are going to involve hydrolysis of the iminium ion. It really doesn't take much acid. This might happen in water because the iminium ion is charged. So the water attacks the carbon adjacent to the nitrogen, and now we have this intermediate that's got both the nitrogen and the oxygen, but it's positively charged because there's two hydrogens on the oxygen. So the next thing that happens is we deprotonate the oxygen to give us the OH. Proton on, something happens, proton off, proton on, something happens, then proton off. Okay, good. The next step is we protonate the amine to give us this intermediate. We're making the nitrogen a better leaving group. So here we are on a new screen to give us a little more space. The nitrogen is a better leaving group, so it leaves. And it gives us this carbocation intermediate, which can be deprotonated to give us the product, which is a 1,5-dicarbonyl. The advantage of this method is we didn't use any strong bases, so this is much safer. It's probably okay if a little bit of water gets in our sample. With the other strong bases, you need to be careful about letting water get into your sample, and you probably also need to be more worried about dangers, fire.